Hi, everyone. So I'll be talking about algorithmic systems, transparency, accountability in the big data era. These are very recent issues that many of community researchers in different disciplines are really now paying a lot of attention, as far as there are several implications from the research point of view, but also on people and on the society. So I'll be okay. I need to push it. In fact, a very quick words about the evolution of data analytics from looking to the past and then now moving for predictive and prospective analytics. In fact, very quickly, I will not be very long on this slide, is to say that, the main point here is that big data technologies are enablers for AI capabilities, which is very important really to see this idea, because sometimes we can put different definition behind several of these vocabularies about big data and AI, and that's why we are moving from data analytics to cognitive systems. But I like also the expression of Guru Barnavar, who is the scientific director of IBM Watson, saying that it's augmented human intelligence. In fact, it's not really artificial intelligence, but AI capabilities today, in fact, enhance the human capabilities. In fact, we afford sometimes to keep our brain thinking and working on different tasks. That's why there is, of course, we need to learn new things. We need to have new jobs. We need a societal adaptation for these AI results, definitely, but it's not my point here today. Anyway, I would like to say two also ideas about barriers and drivers. The drivers are very obvious. The talks today provide very nice examples of what big data technology can provide, and data science performances and capabilities are in continuous growth, but also new business models for value creation, and the examples and the use cases are really many. But a very important thing, in fact, is the data and algorithm duality. Data without algorithm is, I can say nothing, but also the contrary. I'm exaggerating somehow, and also algorithm without data. It's a process without the content, there is no value. So when we say there is data everywhere, we need to say also there is algorithm everywhere, in fact. So this is a very important point, and I'll go back to this point later. With regards to the barriers, of course, whatever the performance is of our big data technology, still the trust and the appropriation remain a key issue. So the data and algorithmic transparency and accountability is now a really emergent topic at several levels and communities. I can mention the data veracity, but also the quality and usage conditions of algorithm, because of today, there is a lot of open source of machine learning and data analytics, and we are more in the reuse of algorithm and solutions. So the users and the person who is deploying data analytics solutions is not the one who has make the consumption of the algorithm. So we need to be careful about this issue also. But also one of the barriers is the interdisciplinary skills. I really put an emphasis about the interdisciplinary skills in data science is really key. Again, few words just to say that big data is not only data analytics. In fact, the main point in this slide is to say that we had, in fact, work within a Big Data Value Association, who is steering with the European Commission a public-private partnership with regards to big data technologies with €2.5 billion. It's a large program, and in fact, it is gathering industries, but also academia at the European and international level. And we agreed on these 5 pillars for data science. So going from data management, data processing architecture, data analytics, data protection, but also data visualization. I mean, these 5 pillars are very important, and I will not elaborate. We can maybe discuss if you are interested. I mean, these pillars are still also subject to ongoing research, so not everything is solved here, of course. But what I would like to emphasize, in fact, are these main R&D challenges. One of them, of course, progressive user-centric analytics, which is about online learning. In fact, giving the place to the user to interact. And then we are talking about real-time learning from few examples, which is really difficult, problem. From the technical side, from this research side also, but also making the difference and developing more approach based on causality rather than correlation, which is really important issue here, but also seamless co-evolution between humans and machines. And the second R&D challenge is about really the energy efficient and optimized architecture for big data technology. I mean, if big data technologies have a limit, it will be energetic limit. So we should keep it in mind, and it's a very important issue, which is not that much addressed by the community. In fact, I would like to focus on this one about scientific and technical methods for transparency, accountability, and explainability, which will be the topic of my following slides. So, in fact, we can even say the most important challenge now is about responsible and ethical data management and analytics methods. I would like to point out here that most of the time, we are considering that, okay, it's for sure objective. It is because it's data-driven. I mean, it's straightforward, and we should believe it. In fact, this expression of data fundamentalism is due to one of these reports I would like to point out, which are very important, very interesting, and I would recommend this report for you. I mean, the White House have made a report on big data for algorithmic system opportunities and civil rights, but also the Federal Trade Commission again. So we should avoid this kind of behavior. That means it's really a mistake to assume that they are objective simply because they are data-driven. So we need to be careful. That's why now we are really fostering the implementation of what we call equity by design or responsible by design principle, looking after fairness, equity, loyalty, neutrality concepts. But I agree that these concepts, some of them could be objective, and some other are fully subjective and difficult to work on. So to provide some insights about some ideas in my previous slide, it's also about mastering big data technology with regards to accuracy. It's also a matter of accuracy. I mean, it's really important from a technical point of view. It's not only from the societal or from the law perspective, it's from the technical point of view. We need to be careful about the accuracy because it could, and there's several studies that shows that it has impact on people's lives. So remember, I was talking about the duality between data and algorithm. So here exactly we have, the kind of bias that I can see here are both sides. The kind of bias we can find from the data point of view, but also the bias from the structure of the algorithm. So from the bias that we can face is simply poorly selected data. It can happen. Whatever the performance of the deep learning algorithm or whatever other learning or predictive approach, if we have poorly selected data, we can be, the outcome is not performant. Which is important is the overall result. So the overall result is also dependent of what we do with the data and what kind of data we are using. So data also could be incomplete, could be incorrect, but also could be simply outdated. We need to be careful also about these aspects. But also what we can face is that a lack of representativity of some given data. For instance, if we have to study the maybe the behavior or we need to understand, let's say behavior coming from data from mobile phones, for instance. It depends whether we are in a city or outside, because it's the density of people having phones. It's not about, you see my point? The representativity of data will depend from the density of devices. So data could be not representative, and so the result of a given study could be completely, out of the out of the expectation and not really relevant, in fact. But we don't also miss the other bias, which is we could have malicious attack on data, which is about the veracity, in fact. So we could have malicious attack, and again, the accuracy will be, will be, of course, have a problem in this case. But this is with regards to data, but with regards to algorithm design, also we can have similar, other sources of bias. For instance, for predictive algorithm and predictive analytics, in fact, we are learning from the past, and somehow we are reproducing the past, which is in some application and in some situation a sort of exclusion, because we cannot, if we take into account the previous behavior or the context of a person, plenty of personal data can, in fact, produce exclusion to recommend a given service or product just because from the history it can exclude some option that a citizen can have. So, we need definitely to be careful as far as, data analytics are not only about pushing button and that's it. So this is, in fact, my point to really address the big data accuracy, because, I won't go into the detail because there are several use cases where really there is an issue with only this property, and we see that we are completely, very severe impact if we don't pay attention. So we need to master the deployment of big data technology. It's very important. So, in this direction, the decision responsibility is then an issue. Suppose that we don't use the right data, we don't use whatever with the right matching algorithm or whatever. So it is very important to have at least some insights about the explanation and the traceability of what has been used as criteria, as data, as settings. And in fact, as I used to be a researcher in computer vision and object recognition, that reminds me the first presentation. In fact, sometimes when I used to work with my PhD students, in fact, we have a very interesting scores for recognition of that object and that one. And when we go to see and to analyze the explicative variables, in fact, we realize that the model have learned the context of the object and not the object, which is an issue. So in the computer vision domain, we can see the explainability and we can interpret what is going on. But if we are in other contexts, another domain, it's not the case. So, I mean, that's why we need to be careful. So decision explanation and traceability, robustness to bias, diversion, and corruption are very important issue. So these are some ideas that we share with our colleagues from NSF and with the JST in Japan, which is the Japanese research fund of big data programs there. So we need to open the black box of deep learning. We need to study more the trustworthiness of machine learning algorithm, bias typology, software reuse. I mean, there is several issues behind these topics. Algorithmic explainability approaches, I mean, I don't know whether, oh yes, it's my next slide. The DARPA, which is, I mean, has launched the explainable AI last August. It's very recent, so that also tell us that it's very important to be in situation to understand what is going on and why this decision or why this recommendation have been performed. Let me mention some relevant French programs. So the Transalgo platform, which is very new initiative, launched by Axel Lemaire in mid-December, I mean 15th of December, after the recommendation and the report of the Conseil Général d'Économie. So this is an initiative, and we are working on these topics now to set up this platform, which has the objective to really foster the development of transparency of tools, methods for data and algorithm. Remember again the duality between data and algorithm. So we need to have to master the control of use of data. We need to understand what's going on. I mean, whether a piece of software is doing what is are the specification or is doing more or less, etc., etc. So I will not go into the detail, but just here to mention that fairness and I mean fairness is here I put all together several concepts which has nothing to do together, in fact, but fairness is rather subjective topic, and it depends from use cases. That's why I was suggesting for international community to work together on the fairness definition, which is, I mean, very dependent from several use cases. And also equity, collective equity can be also not very coherent with individual equity. So we need to have a very precise definition and very important work to get these topics very clear and provide, in fact, our effort is to support the law for digital republic, also to provide the technical tools. In fact, it's a matter of algorithm that will analyze the behavior of other algorithms, finally, in fact, if we may say. So the objective of this platform is first to start with a resources center and then a research program, research and development program with the Data Transparency Lab, which is an initiative between MIT and ATT and Mozilla, and Inria has joined the board of GTL, last October. And also the idea is to provide, best practices and provide MOOCs. And the partners in this important initiative are, besides other academia like IMT, there is the Conseil National du Numérique, DGCCRF, which is the French FTC, and other association. It's a huge and important program. I would like also to point out here, it's not only B2C issue, it's also B2B issue. So having such tools, for trust, is also for B2B. I would like to finish with another ongoing initiative which we are also working on, and we are trying to build this initiative, right now with 12 academic institutions in France. It's about Interdisciplinary Institute for Data Research, Intelligence, Value and Ethics. And the idea is to have 4 overreaching challenges. And we found these studies of transparency and accountability here, which is most important is to be accountable. Transparency issue is, in fact, to raise the awareness, whether of a consumer, whether individuals or from professionals. And here, in fact, just to mention that it's interdisciplinary work, gathering data scientists and people from management economy, social science, and legal science. Very quickly, as a conclusion, algorithmic system transparency and accountability approaches are essential for digital trust and appropriation. And the transparency and the responsible by design methods are economical competitiveness factor, which is, it's not only a matter of, okay, I would like to see if whether you are in line with the law or not. It's not only, it's also a competitive and economic competitiveness factor, because for an equivalent service, if for equivalent service, a transparent service providing information about the provenance of data, providing traceability of how decisions have been taken. Of course, it's more interesting for whatever the consumer is. It's more attractive being and having these properties. But also, of course, there are tools for consumers, B2B and B2C, empowerment. This is very important because if someone take and make a choice, he's informed about what choices he will make and he's taking. So it's an empowerment tool and very important in this regard. But again, a tool for regulators to also provide tools, measuring tools of what is going on with these data analytics and big data tools and AI techniques more generally, in fact, in our economy today. And that's it. Thank you.
Nozha, thank you very much.